Perfect. pH-balanced soap.
What? pH-balanced soap? I thought soap was all the same.
No. That's not true. This soap is better for my skin because it's less of a base.
What does that matter?
Well, our skin is acidic. And so if you have a soap that is too basic, it neutralizes your skin, which is bad for it.
Really?
Yeah,
I didn't know that.
it's true.
Think I'll get some too.
Why should we use pH-balanced soap for our skin? How does a neutral substance react with acids or bases? What is a neutralization? Let's find out.
Hi, and welcome to Moonkong Simple Science. Have you ever wondered why you don't just use laundry detergent to wash your face? Well, it's because acids and bases react differently with each other. Let's do some experiments today to see exactly what I mean. Now, in front of me, I have 3 glasses of red cabbage indicator solution. Now, an indicator reacts differently with acids, bases, and neutral substances to produce a change that we can see. When we add an acid to our indicator, an acid donates protons and turns it red. When we add a base, it accepts protons from the indicator and turns it blue. When we add a neutral, however, we see no change in color. This is because the neutral neither accepts nor donates a proton. So in this first experiment, I'm going to try to add different substances to our indicator solution to see how they react. I have in front of me lemon juice, ammonia, and water. So what do you think will happen when I add these to my indicator solution? Let's find out. First, I will add lemon juice. Next, I will add some ammonia and water. So let's take a closer look at what we have here. So we see that the lemon juice has turned the indicator pink. This is because it has donated protons, so it is an acid. The ammonia has turned the indicator solution green. This is because it accepts protons from the indicator, so it is a base. On the other hand, the water has not changed the color of our indicator solution. This is because it neither accepts nor donates protons. It is neutral. So in our second experiment, we will see what happens when we mix neutral water with an acid and a base. So what do you think will happen when we add this water? Let's see. So let's take a closer look at our glasses. So what you can see is the color of both the acid and the base have not changed when we've added water. This is because the water does not accept or donate protons because it is neutral. No reaction happens between these. So for our third experiment, let's bring in another glass of red cabbage indicator solution. We're going to see what happens when we add an acid and a base together. What do you think will happen? So first, let's add some of our acid to the solution. So as we would expect, it turns pink. Let's add some base in. So let's take a closer look at what we have now. So as you can see, the solution has turned purple. This is because the protons donated by the acid have been accepted by the base. So when these two react together, they end up canceling each other out in a process we call neutralization. So we end up with a neutral solution. Let's review what we've learned today. An acid donates protons when it is in a solution. A base accepts protons in a solution. And neutral neither accepts nor donates protons in a solution. When an acid and base react together, they cancel each other out in a process we call neutralization. Well, that's all the time we have for today. I hope to see you next time. Bye.